First, there was standard form, then there was vertex form, and now we have intercept form. So we're going to learn one more form and how to graph it. So today's essential question is, how can knowing the x-intercepts of a function help me to graph that function? Here's what intercept form looks like. As with all of our other forms, we have an a out front that's kind of controlling the stretching. And then we have two binomials. Remember, a binomial is a polynomial that has two terms. So binomial, here's a second binomial. If we have two binomials multiplying together like that, think about the FOIL. This is going to turn out to be a quadratic because I'll have x times x, x squared, and then some other stuff if I go through the FOIL steps. And my x-intercepts are going to be p and q. So let me write that down. The x-intercepts are going to be p and q. Now, I'll leave it as a mystery for now why these are the x-intercepts, but it has something to do with how you find the x-intercept. Remember, the x-intercept are points on a graph where the parabola crosses the x-axis. Isn't the y-coordinate here and here 0? Because I'm going up 0 off the axis. If I plug 0 in for y in this equation, I'll get 0 equals a times x minus p and x minus q. And if you remember, by the zero product property, I can split this equation up and say x minus p equals 0, also x minus q equals 0. That means that the x, if we solved this equation, would be p, and the x would be q. So again, this sort of solving is something that you have done before, I promise. We won't talk about it too much for now. We'll get into it later on in this chapter. For now, know that if you have two binomials multiplying each other, the x-intercepts are p and q. So let's take a look at how that looks in a problem. Here we have y equals 3 times x plus 2 and x plus 6. Remember that intercept form was a times x minus p and x minus q. So since I have the minus signs there, the intercepts are going to kind of be the opposite of what I see here. So my x-intercepts are going to be -2 and -6. In the immortal words of Mr. Dusty Smith, binomials lie. The binomials typically do the opposite of what we want them to, and that's because I have these minus signs here. So let's go ahead and graph those on the graph. I have an x-intercept at -2. I have an x-intercept at -6, which I believe is here. But now I have an issue. I know that there's a parabola going through there somehow, but I don't know how to find the vertex. But let's think about this for a second. Isn't a parabola symmetric, okay? So a parabola is symmetric. That means that the vertex, the middle point, should be directly in between these 2 points. So if I take the average of these 2 points, that will give me the x-coordinate of the vertex because of symmetry. So let's take an average of the 2 points. If I average -2, -6, I add them up, I divide by 2, that would give me -8 over 2, which is -4. And if you notice, -4 is directly in between -2 and -6. So this is the x-coordinate of the vertex. I need to find the y-coordinate, of course, and to plug the y-coordinate, let's just plug in -4 and see what the y-coordinate ends up being. So y equals 3 times, I'm plugging in -4 for my x to figure out what the y-coordinate is that matches up with that x-coordinate. Let's do parentheses first. So I have 3 times here, this is -2. Here, this is also, oh, no, that's +2. So I have 3 times -2 is -6, times 2 is -12. So my vertex has the x-coordinate of -4 and the y-coordinate of -12. So I'm going over -4, down 12 would be right about here. Typically, I like to graph more than just 3 points, but really 3 points is enough to graph this parabola. I have the vertex, I have 2 x-intercepts, I can make a nice shape. Let's put this property on the first slide. In order to find the vertex, I need to take the average of the two x-intercepts. So I'm going to add up P and Q and divide by 2. That will give me the x-coordinate of the vertex, because the vertex, because of symmetry, will be directly in between. Okay, let's do another example, and let's go pretty quickly still. I have two binomials multiplying each other. So it looks like here my x-intercepts are, remember I'm taking the opposite, the x-intercepts are going to be 4 and -6. So let's go ahead and graph those. 4, I have -6 way over here. This is going to be another one, I think, where the vertex is off the graph. Whoops, shouldn't have done it that way. Oh well. Okay, so remember, to find the x-coordinate of the vertex, I'm taking the average of the two x-intercepts. Or just think finding the number directly in between. So 4 plus -6 over 2. That would be -2 over 2, which is -1. So the x-coordinate of my vertex is -1, and you know that in order to find the corresponding y-coordinate of any x-coordinate, just plug it in. So here we go, I'm plugging it in, do the parentheses first. Remember, this negative is like -1. Here I have -5. Here I would have +5. And so -1 times -5 times 5 is 25. Rather than go crazy off the graph, let's just scale my axes a little bit differently. Let's scale by 5s. So 5, 10, 15, 20, 25. So I'm going over -1 up 25. Here's my parabola. Not too bad, right? The tricky part will be memorizing how to do all of this different stuff for the intercept method and for the vertex method and for the standard form. You need to have all these different techniques memorized, but they aren't too bad if you have them memorized. All right, last thing we can do is we can write this intercept form equation in standard form. Remember when we did that with vertex form? Basically, we just multiplied things out, and that got us to standard form. So in order to get it into standard form, which remember is ax squared plus bx plus c, let's just do the FOIL. 4 stays outside, and I'm foiling. X times x is x squared, x times 2, -7 times x, and -14 on the end. Let's combine like terms real quick. So -5, and I have -14, and finally distribute in the 4x squared minus 20x minus 56. That sounds right. So y equals 4x squared minus 20x minus 56. Sorry for the stumble on my mental math. Not everybody can be perfect, but this is the equation in standard form. I just multiplied everything out. All right? So, summary. When you are graphing an equation in this form, first, find your x-intercepts. Remember, they are P and Q, and because of the minus sign in my intercept method, I'm taking kind of the opposite of what I see in there. Binomials lie. Then I need to find the vertex, as always. To find the x-coordinate of the vertex, I'm going to find the point directly in between those x-intercepts. In other words, take the average, P plus Q over 2. Hey, also as a summary, let me just talk about one quick thing. When I have graphs like this, remember, I can look at the maximum value here. This is the highest the parabola gets, right? The highest it gets is a y of 20. So my max value would be 25. I can also talk about a minimum value, right? On this parabola, my minimum value, the smallest the parabola ever gets, is a y of -12. That's something that will come up in some problems that I haven't explicitly talked about yet. Otherwise, I think I hit everything, so you're welcome, and thank you for watching.